Yellowstone's last major eruption, which formed the caldera, occurred about 640,000 years ago. Its most recent volcanic activity, consisting of lava flows, ended about 70,000 years ago. The volcano is not overdue to erupt, but it is still an active volcano with a large magma chamber deep beneath the surface and a center of hydrothermal features. The last time Yellowstone produced a supermassive eruption, it blanketed the western US, southern Canada, and northern Mexico in ash. If it were to erupt now, the United States Geological Survey says the impacts would be global, with ashfall lasting years to decades and climate change. Montana, Idaho, and Wyoming would be affected by superheated pyroclastic flows. So, what can be done to prevent an eruption? Michael Poland, the scientist in charge of the Yellowstone Volcano Observatory, addresses this question in this week's Caldera Chronicles, a weekly column written by scientists working at the site. Poland said people often ask if Yellowstone could be drilled to relieve the pressure building up underground to prevent an eruption. He said magma reservoirs are much more complex than just large caverns of molten magma. Instead of large balls of molten magma reservoirs are a mushy mixture of rock, molten magma, crystals, and various fluids and gases, with poor interconnectivity and often no clear boundaries between the reservoir and the surrounding rock, he said, explaining that Yellowstone has two magma chambers, one at depths between 4.5 and 16 kilometers below the surface, and the other at depths between 20 and 48 kilometers underground. The pressure in this type of system is not like the air in a balloon and cannot be easily relieved by drilling 1 or even 100 holes into its complex structure, he wrote. In a magmatic system, pressure increases as magma and associated fluids accumulate. The system is like a balloon filled mostly with solid cement, with some loosely connected wet areas filled with gas. Puncturing the balloon won't remove the cement, nor will it reach all the loosely connected wet parts of the system. Poland also said that you can't cool a magma reservoir by pumping water into it. He said that although NASA's Jet Propulsion Laboratory found that such a reservoir could be cooled with sufficient water over thousands of years, their calculations ignored the Yellowstone hotspot, which drives volcanism at that location. Cooling a magma body by pumping water into the subsurface would be like trying to cool a pot of boiling water by gradually adding drops of cold water while leaving the burner on, he said. So you can't prevent an eruption by drilling or injecting water into a volcano, but can you trigger an eruption with a nuclear bomb? That's not true either. The USGS states that earthquakes release enormous amounts of energy. The largest earthquakes release roughly the same amount of energy as a 2,000 megaton nuclear weapon. In 1975, an earthquake released the same amount of energy as a 2 megaton nuclear weapon. This is about 100 times more energy than the one dropped on Hiroshima in 1945. This earthquake occurred right next to Yellowstone's magma chamber, meaning most of the energy was transferred directly to the rock. In a nuclear attack, the explosion would occur above ground, so most of the energy would be released into the air, the USGS said. And guess what happened to the Yellowstone volcano after the 7.3 magnitude earthquake? It didn't erupt. The only impact was some changes in the hot springs and geysers caused by the shaking.